So with the Optimus, do you still see that mission being the mission statement of Tesla, or is it going to be updated with mission to accelerate the advent of I don't know infinite abundance or limitless economy?
Yeah, I mean, it is not strictly speaking, Optimus is not strictly speaking directly in line with accelerating sustainable energy. To the degree that it is more efficient at getting things done than a person, it does, I guess, help with sustainable energy. But I think the mission effectively does somewhat broaden with the advent of Optimus to I don't know, making the future awesome. So, I think you look at Optimus, and I don't know about you, but I'm excited to see what Optimus will become. And, this is like, if you could, I mean, you can tell, like any given technology, do you want to see what it's like in a year, 2 years, 3 years, 4 years, 5 years, 10? I'd say for sure. You definitely want to see what's happening with Optimus. Whereas, a bunch of other technologies are, sort of plateaued. Won't name names here, but so I think Optimus is going to be incredible in like 5 years, 10 years, like mind-blowing. And I'm really interested to see that happen, and I hope you are too.
I have a quick question here. I'm Justin, and I was wondering, are you planning to extend conversational capabilities for the robot? And my second follow-up question to that is, what's the end goal? What's the end goal with Optimus?
Yeah, Optimus would definitely have conversational capabilities. You'd be able to talk to it and have a conversation, and it would feel quite natural. So, from an end goal standpoint, I don't know. I think it's going to keep evolving, and I'm not sure where it ends up, but someplace interesting for sure. We always have to be careful about don't go down the Terminator path. That's I thought maybe we should start off with a video of the Terminator starting off with this, skull crushing, but that might be, people might take that too seriously. So, we do want Optimus to be safe, so we are designing in safeguards where you can locally stop the robot, and with basically a localized control ROM that you can't update over the internet, which I think that's quite important, essential, frankly. So, like a localized stop button, remote control, something like that cannot be changed. But I mean, it's definitely going to be interesting. It won't be boring. So.
Okay, yeah. I see today you have very attractive product with Dojo and its applications. So I'm wondering what's the future for the Dojo platform? Will you provide infrastructure as service like AWS, or you will sell the chip like the NVIDIA business-wise?
Yeah, I mean, Dojo is a very big computer, and actually will use a lot of power and need a lot of cooling. So I think it's probably going to make more sense to have Dojo operate in a Amazon Web Services manner than to try to sell it to someone else. So that would be the most efficient way to operate Dojo, is just have it be a service that you can use that's available online, and where you can train your models way faster and for less money. And as the world transitions to software 2.0.
And that's on the bingo card.
As someone I know has to know to drink 5 tequilas. Let's see. Software 2.0
yeah.
will use a lot of neural net training. So it kind of makes sense that over time, as there's more neural net stuff, people will want to use the fastest, lowest cost neural net training system. So I think there's a lot of opportunity in that direction.
Hi, my name is Ali Jahanian. Thank you for this event. It's very inspirational. My question is, I'm wondering, what is your vision for humanoid robots that understand our emotions and art and can contribute to our creativity?
Well, I think you're already seeing robots that at least are able to generate very interesting art with like DALL-E and DALL-E 2. And I think we'll start seeing AI that can actually generate even movies that have coherence, like interesting movies and tell jokes. So it's quite remarkable how fast AI is advancing at many companies besides Tesla. We're headed for a very interesting future. And yeah, so you guys want to comment on that?
Yeah, I guess the Optimus robot can come up with physical art, not just digital art. You can ask for some dance moves in text or voice, and then you can produce those in the future. So it's a lot of physical art, not just digital art. Yeah.
Oh yeah. Computers can absolutely make physical art. Yeah. 100%.
Yeah, like dance,
Sure.
play soccer, or whatever you. I mean, it needs to get more agile, but over time, for sure.
Thanks so much for the presentation. For the Tesla Autopilot slides, I noticed that the models that you were using were heavily motivated by language models. And I was wondering what the history of that was and how much of an improvement it gave. I thought that was a really interesting, curious choice to use language models for the lane transitioning.
So there are sort of two aspects for why we transitioned to language modeling. So the first...
Talk loud and close.
Okay.
It's not coming through very clearly.
Okay, got it. Yeah, so the language models help us in two ways. The first way is that it lets us predict lanes that we couldn't have otherwise. As Ashok mentioned earlier, basically when we predicted lanes in sort of a dense 3D fashion, you can only model certain kinds of lanes, but we want to get those crisscrossing connections inside of intersections. It's just not possible to do that without making it a graph prediction. If you try to do this with dense segmentation, it just doesn't work. Also, the lane prediction is a multimodal problem. Sometimes you just don't have sufficient visual information to know precisely how things look on the other side of the intersection. So you need a method that can generalize and produce coherent predictions. You don't want to be predicting 2 lanes and 3 lanes at the same time. You want to commit to one, and a generative model like these language models provides that.
Hi. Hi. My name is Giovanni. Yeah, thanks for the presentation. It's really nice. I have a question for FSD team. So for the neural networks, how do you test, how do you do unit tests, software unit tests on that? Like, do you have like a bunch, or I don't know, maybe thousands or cases where the neural network that after you train it, you have to pass it before you release it as a product, right? What's your software unit testing strategies for this, basically?
Yeah, glad you asked. There's like a series of tests that we have defined, starting from unit tests for the software itself, but then for the neural network models, we have VAP sets defined where you can define. If you just have a large test set, that's not enough. What we find, we need like sophisticated VAP sets for different failure modes, and then we curate them and grow them over the time of the product. So over the years, we have like hundreds of thousands of examples where we have been failing in the past that we have curated. And so for any new model, we test against the entire history of these failures and then keep adding to this test set. On top of this, we have shadow modes where we ship these models in silent to the car, and we get data back on where failing or succeeding. And there's an extensive QA program. There's like 9 levels of filters before it hits customers. But then we have really good infra to make this all efficient.
And I'm one of the QA testers. So I QA the car
Yeah,
like
QA tester.
yeah. So I'm constantly in the car just being QAing like whatever the latest alpha build is that doesn't totally crash.
Finds a lot of bugs.
Yeah.
Hi, great event. I have a question about foundational models for autonomous driving. We have all seen that big models that really can, when you scale up with data and model parameter, right, from GPT-3 to Palm, it can actually now do reasoning. Do you see that is essential scaling up foundational models with data and size, and then at least you can get a teacher model, right, that potentially can solve all the problems, and then you distill to a student model. Is that how you see foundational models relevant for autonomous driving?
That's quite similar to our auto labeling model. So we don't just have models that run in the car. We train models that are entirely offline, that are like extremely large, that can't run in real time on the car. So we just run those offline on the servers, producing really good labels that can then train the online networks. So that's one form of distillation of these teacher-student models. In terms of foundation models, we are building some really, really large data sets that are multiple petabytes. And we are seeing that some of these tasks work really well when we have these large data sets. Like the kinematics, like I mentioned, video in, all the kinematics out of all the objects, and up to the fourth derivative. And people thought we couldn't do detection with cameras. I mean, detection, depth, velocity, acceleration. And imagine how precise these have to be for these higher order derivatives to be accurate. And this all comes from these kind of large data sets and large models. So we're seeing the equivalent of foundation models in our own way for geometry and kinematics and things like those. You want to add anything, John?
Yeah, I'll keep it brief. Basically, whenever we train on a larger data set, we see big... OK. Basically, whenever we train on a larger data set, we see big improvements in our model performance. And basically, whenever we initialize our networks with some pre-training step from some other auxiliary task, we basically see improvements. The self-supervised or supervised with large data sets both help a lot.
Hi. So at the beginning, Elon said that Tesla was potentially interested in building artificial general intelligence systems. Given the potentially transformative impact of technology like that, it seems prudent to invest in technical AGI safety expertise specifically. I know Tesla does a lot of technical narrow AI safety research. I was curious if Tesla was intending to try to build expertise in technical artificial general intelligence safety specifically.
Well, if it starts looking like we're going to be making a significant contribution to artificial general intelligence, then we'll for sure invest in safety. I'm a big believer in AI safety. I think there should be an AI sort of regulatory authority at the government level, just as there is a regulatory authority for anything that affects public safety. So we have a regulatory authority for aircraft and cars and sort of food and drugs. And because they affect public safety, and AI also affects public safety. So I think, and this is not really something that government I think understands yet, but I think there should be a referee that is ensuring or trying to ensure public safety for AGI. And if you think of what are the elements that are necessary to create AGI? The accessible data set is extremely important, and if you've got a large number of cars and humanoid robots processing petabytes of video data and audio data from the real world, just like humans, that might be the biggest data set. It probably is the biggest data set. Because in addition to that, you can obviously incrementally scan the internet. But what the internet can't quite do is have millions or hundreds of millions of cameras in the real world, and with like I said, with audio and other sensors as well. So I think we probably will have the most amount of data, and probably the most amount of training power. Therefore, probably we will make a contribution to AGI.
Hey, I noticed the semi was back there. but we haven't talked about it too much. I was just wondering for the semi-truck, what are the changes you're thinking about from a sensing perspective? I imagine there's very different requirements, obviously, than just a car. And if you don't think that's true, why is that true?
No, I think basically you can drive a car. I mean, think about like, what drives any vehicle. It's a biological neural net with eyes, with cameras, essentially. So if and really, what is your primary sensors are two cameras on a slow gimbal, a very slow gimbal. That's your head. So if you know, if a biological neural net with two cameras on a slow gimbal can drive a semi-truck, then if you've got like 8 cameras with continuous 360-degree vision, operating at a higher frame rate and much higher reaction rate, then I think it is obvious that you should be able to drive a semi or any vehicle much better than a human.
Hi, my name is Akshay. Thank you for the event. Assuming Optimus would be used for different use cases and would evolve at different pace for these use cases, would it be possible to sort of develop and deploy different software and hardware components independently and deploy them in Optimus so that the overall feature development is faster for Optimus?
Okay, all right. We did not comprehend. Unfortunately, our neural net did not comprehend the question. Yeah, so, well, next question.
Hi, I want to switch the gear to the autopilot. So when you guys plan to roll out the FSD beta to countries other than US and Canada? And also my next question is, what's the biggest bottleneck or the technological barrier you think in the current autopilot stack? And how you envision to solve that to make the autopilot is considerably better than human in terms of like performance matrix like safety assurance and the human confidence? And I think you also mentioned for FSD V11, you are guys going to combine the highway and the city as a single stack and some architectural big improvement. Can you maybe expand a bit on that? Thank you.
Well, that's a whole bunch of questions. Well, we're hopeful to be able to, I think from a technical standpoint, FSD beta should be possible to roll out FSD beta worldwide by the end of this year. But for a lot of countries, we need regulatory approval, and so we are somewhat gated by the regulatory approval in other countries. But I think from a technical standpoint, it will be ready to go to a worldwide beta by the end of this year. And there's quite a big improvement that we're expecting to release next month. That will be especially good at assessing the velocity of fast-moving cross traffic and a bunch of other things. So, anyone want to elaborate?
Yeah, I guess so. There used to be a lot of differences between production autopilot and the full self-driving beta, but those differences have been getting smaller and smaller over time. I think just a few months ago, we now use the same vision-only object detection stack in both FSD and in the production autopilot on all vehicles. There's still a few differences, the primary one being the way that we predict lanes right now. So we upgraded the modeling of lanes so that it could handle these more complex geometries like I mentioned in the talk. In production autopilot, we still use a simpler lane model, but we're extending our current FSD beta models to work in all sort of highway scenarios as well.
Yeah, and the version of FSD beta that I drive actually does have the integrated stack. So it uses the FSD stack both in city streets and highway, and it works quite well for me. But we need to validate it in all kinds of weather, like heavy rain, snow, dust, and just make sure it's working as better than the production stack across a wide range of environments. But we're pretty close to that. I mean, I think it's, I don't know, maybe it'll definitely be before the end of the year, and maybe November.
Yeah, in our personal drives, the FSD stack on highway drives already way better than the production stack we have. And we do expect to also include the parking lot stack as a part of the FSD stack before the end of this year. So that will basically bring us to you sit in the car in the parking lot and drive till the end of the parking lot at a parking spot before the end of this year.
Yeah, and in terms of the fundamental metric to optimize against is how many miles between a necessary intervention. So just massively improving how many miles the car can drive in full autonomy before an intervention is required that is safety critical. So yeah, that's the fundamental metric that we're measuring every week, and we're making radical